graders, it's Mrs. Thompson. We're going to do 4.9 example 2 today, and I don't think this will take too long. I think this will probably be a really simple lesson, especially if you just got done watching example 1. We're going to do a geometry application today, and what our job is, we want to prove that ABCD is actually a parallelogram. So as you may recall, I don't know how much geometry you've had, but a parallelogram, let me define that for you. What you have here are two pairs of parallel sides. Two pairs of parallel sides. And those sides, those parallel sides, are opposite of each other. Okay, so just to recap, parallelogram, we've got two pairs of parallel sides, and the parallel sides are opposite of each other. So what we're looking at is we want to see if AD and BC are parallel. That's what we're interested in. And then we want to see if AB and DC are parallel. So those are opposite sides. And we just want to double check that. There's a number of ways to do that, and I'll give you my first and foremost favorite is rise over run when checking slopes, okay? So here are your options. Option 1, you could use rise over run and just count. Option 2, you can use the slope formula. Pick the 2 points, plug them in, compare the slopes. You'll have to do that a couple of times. Sorry, I tried to write M again. It's x2 minus x1. So you can use either one. I don't think it really matters. So as you're looking at AD, segment AD, you want to, we'll start down at the D, and we want to rise 1, 2, 3, 4. So we went up 4, but we're not going over anywhere. We got to that next point, so we didn't move at all. Okay? And then I want to check BC. And you can also see this visually. I'm going to start at C. I'm going to go up 1, 2, 3, 4. So I went up 4, and I'm not moving at all right or left. And so they're both vertical lines, first of all. And I just showed you numerically that the slope is undefined. So they both share the same exact slope. We're dividing by 0, which we can't do. So that means they have an undefined slope. AD and BC have undefined slopes, and that means that they must be parallel. So in geometry, the way that we write this is that we write segment AD, and we do 2 long skinny lines to indicate parallelism. And so what that statement says right here is segment AD is parallel to BC, and I proved it numerically. We're dividing by 0 in both of them, which means they are undefined. They have undefined slopes. Okay, so we've proven one pair of parallel sides. Now we've got to prove the other pair. So let me get my eraser out, and I just need a little bit of room. You know me, I got to erase everything, give myself some space. All right, let me get my pen back up here. This time what we want to look at is AB and DC. That's what we want to look at. We want to study those two opposite pairs, okay, opposite sides. So AB, if you use rise over run, you can start here and you go up 2, okay, and then right 1, 2, 3, 4, 5, right 5. Okay, let's try DC. Start down here at D. Let's go up 2, and then right 1, 2, 3, 4, 5. Looky there. Same exact slope. They both have the same exact rise over run, or the same slope. So we can say assuredly that segment AD is parallel to BC, and segments AB and DC are also parallel. So we can prove that, and you can do that rise over run. Your other option is to name the actual point. So D lies at -1, +1, A lies at -1.5, and you could actually plug the points into the slope formula. I think that would be a little more laborious for you, probably take a little more time than just eyeballing it and counting rise over run. I think that would probably be the easiest way to handle this. Please bring your questions to class. As always, happy to help.